In this video, we solve this differential equation. Let's first assume a solution is proportional to e lambda x, and we're going to look at the differential equation when it's equal to 0. Now we can substitute y equals e to lambda x. We need to take the second derivative and the first derivative. The second derivative is lambda squared times e to the lambda x. The first derivative is lambda times e to lambda x. And now we can factor out a e to lambda x and get lambda squared minus 12 lambda plus 36 equals 0. We know e to lambda x is never going to equal 0, so we divide both sides by that and are left with lambda squared minus 12 lambda plus 36 equals 0. Now at this point I can factor it into lambda minus 6 quantity squared equals 0, and so we get lambda equals 6 with multiplicity 2. Okay, now we can find what our solution is, part of it rather. So the roots are going to be the exponent of the solution, and because there's multiplicity 2, that means we have to write this out 2 times. The first time will just be c1 in front of the e, and the second time we need to include x. So it'll be c2x times e to 6x. Okay, now we want to determine the particular solution by method of undetermined coefficients. So that's going to be our y sub p, and that's going to equal x squared times the quantity a times e to the 6x plus bx times e to the 6x. And we're going to use x squared because we have an x over here. Okay, so now we want to plug it into the differential equation, which means we have to find the first and the second derivative. So the first and second derivative is a little complicated because we have to use the product rule a couple times. So when you plug in the second derivative and the first derivative and then the particular solution in for y, you end up with 2a times e to the 6x plus 6bx times e to the 6x, and that's just going to equal the right side, which I distributed and rewrote. So I did 5 times e to the 6x is 5e to the 6x, and then 3x times e to the 6x over here. I did in that order because now I can just compare the first two and the last two. So if I compare the first two, I ignore the exponential and just say 2a equals 5. And then the second one, I ignore x e to the 6x and see it's 6b equals 3. So that means a has to be 5 halves and b is 1 half. So this was my particular solution. And so I substitute a equals 5 halves and b equals 1 half. And then finally, I can combine what I found originally for the homogeneous differential equation, which is these first two terms, and then adding that to the particular solution. And so this is my final answer.